Hello everyone, welcome back. This is Engineer Hussein Mosapi, and in this video we'll be looking at relative molecular mass versus molecular mass itself. So before we begin, don't forget to hit that like button and subscribe. Alright, let's get to it. Now let us understand firstly what relative molecular mass is. Now relative molecular mass is defined to be the weighted mean or average mass of a given molecule compared with 1/12 of the mass of an atom of carbon 12. You need to understand that. Now this involves compounds that contains ions. Now because of the size of the ionic compounds that we look at, if you look at their lattice structure, you'd find that they will have a giant lattice structure. So we cannot really use the concept of it being a single molecule because that will be misleading to most of you. So be mindful that the relative molecular mass just involves a weighted average mass of a given molecule compared with the most abundant isotope, which is carbon 12. So that is what it involves. Now you need to also know that the relative molecular mass is sometimes referred to as the relative formula mass, and it is one that provides us the sum of all the relative atomic masses of the elements present in that particular formula that has been given. It's basically doing the same thing. The difference is for the relative formula mass, it's like I'll just give you a formula mass of a given compound. It could be an ionic compound like table salt, which is sodium chloride, and I'll expect you to find that relative formula mass. And because it's relative, the values will have what? No units. Alright, let me give you an example to easily understand this. So let's say we've been told to find the relative molecular mass, or let's say they said find the relative formula mass, because the procedure will be one and the same. Say we have that of oxygen gas. So since it's oxygen, the first thing we're supposed to do is to extract the element, which is oxygen, that we have according to the periodic table. First we identify the number of atoms present in this formula, of which we have the subscript 2, which is present there. So we have oxygen sub 2. So this tells us to say that we have 2 atoms of oxygen being multiplied by the atomic mass of what? Oxygen. And the atomic mass of oxygen is 16 on the periodic table. If you multiply 2 times 16, you get 32. Therefore, the formula mass, the relative formula mass of oxygen is 32. You know, when there's a 2, it simply means it's oxygen gas. We do the same thing for water. So we get oxygen. Oxygen, we have 1 atom of oxygen. We say 1 times 16, giving us 16. Then we get hydrogen. We identify the number of atoms of hydrogen present, which is 2, times the mass, the atomic mass of hydrogen on the periodic table, which is 1.008. And if you multiply 2 by 1.008, this will give you 2.016. Remember, the formula mass tells you the sum of all the relative atomic masses that are present in that formula. So if you look at all the elements present in this formula, you have hydrogen and oxygen. If you sum up all its constituent atomic masses that are present there, you will get your relative formula mass. So if I sum up these atomic masses present, 16 plus 2.016, I will get my final relative formula mass that I need. And in this case, we'll get something that will be 18.016. Now remember, since it's relative, we don't really have to put any unit, so it's just going to be 18.016 as your final answer. Now with this in mind, let's try to see how best we can distinguish relative molecular mass from our common friend, which is molecular mass. Now when just say molecular mass is just simply the sum of the atomic masses of all the constituent atoms in a single molecule. When it comes to molecular masses, we're just focusing on a single molecule. It literally just determines the mass of a single molecule. Now you need to understand that unlike relative molecular mass in general will have units, and it will be measured in what are known as atomic mass units, the AMU. So in most cases, you would say you have a question where they say find the molecular mass of oxygen and that of what? Water. So for oxygen, you get the oxygen right there. You determine the number of atoms present. You have 2 times 16, giving you what? 32. Therefore, you have the molecular mass of oxygen to be 32, atomic mass what? Units. You apply the same concept for water. So you start with oxygen, the number of atoms, you have 1 times 16, giving you a 16. You go to hydrogen. Hydrogen has 2 atoms times the atomic mass number on the periodic table, which is 1.008, which will give you 2.016. You sum it up, you'll get 18.016. Now the final answer will be 18.016 atomic mass unit. So this is basically the same thing. We're trying to apply the same procedure when it comes to relative molecular mass and just molecular mass itself. The only difference is that when it comes to molecular mass, it will have units and it will consider that of ions and not just a single molecule. That's something you should know, because at times they might ask you to say differentiate relative molecular mass from molecular mass, and that's why you have to understand that relative molecular mass looks at ions, because ions have a giant lattice structure. But if you look at the molecular mass, that just deals with a single molecule on its own. And be mindful that the procedure that we have in calculating these two entities is one and the same. You just have to know the difference that exists there. Alright, this is everything you need to know about relative molecular mass and just molecular mass itself. Alright, thanks for watching. Don't forget to like and subscribe. Remember, slow progress is better than no progress. And don't forget to strategize before becoming a statistic. Let's try and push for that A+.